Commercial VR systems use dedicated hardware like laser beam stations to track devices, which often can cost thousands of dollars. On the other hand, low-cost mobile-powered VR devices have attracted a lot of attention recently, but the tracking accuracy is not comparable to the commercial VR systems. To fully unleash the potential of mobile VR, we present MoiréBoard, a novel camera tracking method using the moiré effect. Moiré effect is an intriguing phenomenon which commonly exists in our daily life. When two repetitive patterns are placed together, an interesting new pattern appears, and this pattern changes based on the position of the two layers. Consider two grid patterns here. When they overlap together, a larger grid pattern appears. An interesting feature of moiré effect is, when we fix one grid and allow another to move gradually, the moiré pattern also moves, but with much higher speed. Additionally, the moving direction is also determined by the base grid. This allows us to measure the subtle movement of the base grid by analyzing its moiré pattern. In the camera projection scenario, consider two grid patterns that stay at a fixed location. When the camera takes a photo of this scene, the projection of these two grids will form a moiré pattern on the captured image. When the camera moves subtly, the projection of the two grids move at different speeds in the image space, so the moiré pattern also changes. This suggests we can determine the camera location by analyzing the moiré pattern. We implement this idea using a two-layer design. The first layer is a tablet which displays a grid pattern. The second layer is a 3D printed mesh. When the camera sees through the mesh, the moiré pattern can be seen clearly, and the pattern changes as the camera position changes. The four visual markers are used for determining the region of the moiré pattern. Once the moiré pattern is located, we apply a perspective transformation to convert the moiré pattern to a canonical view. Our theoretical analysis shows that, if we measure the period of the moiré pattern and the pixel coordinates of each moiré peaks in horizontal and vertical directions, the 3D positions of the camera can be precisely calculated by using those quantities measured in the image space. We demonstrate our method using a mobile VR system. From the captured image of the MoiréBoard, we can estimate the motion of the camera and use the estimated motion to render a virtual scene that can be displayed on a VR headset in real time. As we can see here, the camera motion in the VR scene precisely matches the camera motion in the real scene, even at some extreme angle. We also perform quantitative experiments on our system. Our evaluation shows that our system has comparable performance as state-of-the-art commercial VR systems, with a much lower cost. Please see our paper for details. Thank you for watching.